record this computer. Do we normally record on the cloud or computer? I usually record on my own computer. Okay, again. Sorry about that, guys. Let's move on. So far, you make it like you survived the first 6 weeks, right? Yay. I don't sound like exciting, but yeah, I do like a minute. So you have learned a lot of things, and you have built a lot of apps, even though it's small, but it's very good to practice your skills in React and HTML and JavaScript. So you have learned how to build converter, to-do list. This is it's a goal. Like you do this in every language or framework, and super awesome game. What game is this? Oh, the Canvas game. Yeah. I like it. Google News client. We also build not Google News. Twitter clone. It's a very fun project. Rock paper scissors. This is to practice on how to use style and blocks in React. The movies database, GitHub clone, issue clone. In this, it's not in this. It's something like ITV, right? So we have built like 10 apps. So what's your most favorite project here in the 10s of the 10s? Nothing? I saw you like shaking your head. Personally, I like the GitHub issues without using React Router at all. So GitHub issue without using React Router is actually train you how to use style and block, and you may need this in the future. And also, to build those apps, we need to know how to use these like text or these concepts. You need to learn a lot in the last 6 weeks. I agree. So we learn in other HTML, CSS, and Scrum, how to be a Scrum Master, how to be a normal dev inside a team, how to be a product owner. We also learn how to use Git and GitHub, right? Aside from GitHub, we have a couple of more tools like GitLab, Gitbucket, or some other things. But GitHub is the most famous one for public use. We also learn some prototype or method for array, for example, filter, map, and reduce. And I would say reduce is like the most powerful one in a couple of methods here. Okay. VS Code, yes. Aside from VS Code, you can use Atom as well. Fetch, it's like to get the data from the APIs or to send some data to the API, right? Aside from using Fetch, you can use ASOS, which is very popular among the devs. And JavaScript, yes. This should be on the top. APIs, this is very important. And you learn how to call API maybe on Wednesday. Okay. This week, Wednesday, React, styles, and blocks, hooks. Hooks is new. It just came out last year. And it's gaining like the majority, like people are changing to hooks now. If you look at the tutorial online, you still see class-based components, right? But people are changing to hooks, and because hook is easier to use, much easier to use, and shorter to write code. React Router, yeah, we just seen it last week. So we have learned a lot. This looks so bad, sorry. Okay, so you have learned how to build like your brand and learn how to think grammatically. Suppose, not really, but suppose so. And then in the next couple of weeks, you may need to know how to formalize how you think. Like in the backend side, if you want to do stuff, you have to think beforehand, like to think ahead, because it's very hard to change midway. You may have to erase everything and do it again. That's why it's very good if you formalize how you think right now, think before you do. And it requires a lot of practice and experience. So this is the main topic for this week. Monday, algorithms to train you how to think and solve the problems step by step. Okay. Tuesday, we will learn Node.js, introduction to Node.js, and we will build a very simple to do app using the command line. Okay. Wednesday, we learn Express, which is a framework for Node.js, and the MVC design pattern. And we will do a lab about the weather app on the backend side. Okay. We already know how to do it on the front end side, but now we need to do it on the backend side by calling API as well. And Thursday, we will learn more about Express and how to use the middleware. And we will have a very fun app, for example, as a meme maker. Basically, you create an app like this. You can upload the file. And so here's the file uploaded. Oh, there's it now here. And you can add text on it, on top or bottom, and produce a meme. Okay. Oh my God, there were like only 3 or 4 pictures earlier. Okay, so you will build this app and make it beautiful. Okay. Oh my God, what? You can share, you can copy the link here and share to other people. It works. Okay, that's the main topic for this week. So let's go to Monday topic. Today's topic, algorithm. Okay. All right. I need to check the question on Discord. No. How do I see the chat? Shit. Oh my God. Thank you. Okay, no one asked. Oh. Okay, algorithm is not very radical in this course, to be honest, right? But it's very useful. I already said it. It's very useful on how to know, so you need to know how the program, the computer works, and you have to think like a computer. Okay. So here's the most famous example here. Max Howell. He's the creator of Homebrew, which is a tool that you use a lot on Mac. For Mac user, you use Homebrew a lot. I swear, I use it too. And he went into an interview with Google. He failed. He failed on the whiteboard challenge. Whiteboard challenge, yeah. Google interviewer gave him a question about the binary tree, and he failed. He couldn't solve that problem. He failed, even though like 90% of the employees in Google use his tool, but he still failed the interview. And he went home and write this on his Twitter. Okay, even though you're good, but if you don't know how to solve a problem on a whiteboard, you may fail the interview. It's very simple. Okay. So maybe shit happen. You don't know, but I think it's good if he failed because like he can find a better job. And today we focus mainly on sorting. Sorting is the basic and the most like challenging topic. Actually, the database use a lot of sorting in their behind the scenes. For example, you want to find something in the database. Actually, it's try to sort it first, and then it grab the piece of data and then return to the user. So sorting is very important, and we need to know how it works behind the scenes. Okay. So normally you will use .sort here in JavaScript, .sort, or Python is sort or sorted. JavaScript you use .sort. It's a method, right? It's a built-in method. But how does it work? How does it work behind the scene? We don't know. It's a combination of different sorting algorithms. So we need to know the big O first. You may say, what the hell is big O? Big O is very crazy. When you hear the word big O and you don't know, you have no idea what it's about, you may freak out, right? But big O or big theta or big omega, they're very simple. That means here, big O like the time it needs to run something, right? To execute something. Big theta is like big O is the worst case scenario. Sorry, the worst case scenario. Big theta is I don't remember. Maybe the best the best scenario, or big omega is like the average scenario. Okay, So I have three: the worst, the best, and the average. Maybe this one is the best. I don't remember the order, but it means those things, three things. We mainly focus on big O when we talk about the runtime. Okay. They can also refer to the space complexity, but normally we only refer to time complexity, time, runtime, not the memory. Memory means space inside your computer. For example, RAM. It takes like 100 megabytes of RAM to do this task, and like 1 second to do that. So 100 megabytes is the memory complexity, and 1 second is the runtime. In this topic, we only focus on the time. Okay. Space memory complexity is hard. It's very hard. So we don't focus on that today's topic. And we have big O, and we have something called ON, O and then N. So you might wonder, O is big O and N is you may wonder what is N. N around here, N is the length of the input. For example, you have an array of N elements. So N means the length of the array, -1, maybe, yeah. So you have a couple of examples so that you can understand more. Don't worry. Oh, I have something to say first. You may not understand anything of this today. It's okay. It's fine. As I said before, you don't need to know this in order to pass this course, right? This is just for people who are interested in backend and want to focus on it a lot. So people talk about big O, so to measure how fast is your algorithm usually. So here's an example of finding the maximum number inside an array. Okay, we have an array X. X is an array. Okay, when we have an array X or a list X, and our job is to find the maximum number. So first we have to temporarily assign max to the maximum number to the first element inside an array. And then we look through the whole array to find the maximum, compare one by one with the max number to find the next maximum number, and then lastly, return it. So to do this, we have to do, how many steps do you think that we need to finish to find the max worst case scenario? Worst case, big O. How many steps? Like how many? Yeah, the length of the array. So what is this? S length, S dot length, right? Yeah, so it's ON. So N is the length of the array X. Right. Smith, yes?
You go a bit slower than this.
Sorry. The whole thing here justifies the maximum number inside in an array, right? So there are a couple of ways to do it. So this is the very simple way, the most straightforward way. You just wrap the first element, assume it is the maximum one, and then just compare that with the next element inside the array. If the next is like greater than the max, the current max, you reassign max to that number. Okay, just keep on doing that until we reach the end of the array, and then return max. Cool. So to do this, the worst case scenario is, for example, max is like assume your last element will be the greatest, the maximum number. So we have to do all the steps. X dot length. This is the Google show. So we have, so let's focus on the sorting. We have the most stupid one, sorting algorithm, Bogo sort. What it means is it's just like we randomly shuffle an array until it's sorted. Like assume that you have a deck of cards, 52 cards, right? Just shuffle it until they are in order from 1 to K, from A to K. Just keep shuffling it and check it. If it's not sorted, you shuffle again. So you depend a lot on luck here. That's why it's very stupid. you may never have a shorted deck. So the whole pseudocode is like this. Oh, it's JavaScript. It's not pseudocode. So the whole logic is like, if the card is not shorted, we keep shuffle it, and then if shorted, we return the whole card. That's it. Very simple. But we have to do so. But the code looks simple. But we need to define shorted. How do we check shorted? How do we shuffle it? So these are the two typical things. To check if it's short or not, we use the same algorithm here. Like we have to look through the whole array to check if the next element is greater than the reverse element. Yes, it's die. Okay, and then we shuffle. We have a bunch of different ways to shuffle a cards, a deck of cards. So I will explain it more in the lab. Okay. Okay, here's how it works. Yes. So this is the function to check if the deck is shorted or not. Very similar to what we've seen. And here's how we shuffle. Looks long. Okay, can you guess what's the big O for the BOGO short algorithm? No, it's crazy, man. How do you call this? The factorial of n, right? The, exponential is they call it factorial. Factorial n. Zyter in Vietnamese. So it's a crazy number. It's like you keep adding, multiply it here.
I have a question.
Oh, infinity is, it's not really infinity, but yeah, it's kind of like that.
I have a question.
Yes.
Why is the worst case is factorial n? Because you basically you randomize it, so you may have repeated. The factorial n is the number of the permutation, though. So
it's very hard. Oh, sorry.
Sorry, do you hear me?
Yeah, I hear. So when you talk about like factorial of n, so it's kind of like you cannot measure it like 100% correct. So usually people will call this factor of n like it could be impossible, or it's the worst in the worst. You will see the in the graph. I will have a graph later on. You will see it on the graph. Like usually the uses means like it's the worst of the worst scenario.
Okay.
Yeah, like because we cannot like measure it correctly, like 100% correctly, so we just like estimate it. All right, everything here is estimated. Okay, a little bit. Yeah, you may have like a chance that it could never be shorted. So here the chart you asked before, it's kind of like infinity. It could be. See, it's the worst of the worst. And better yet, we have like 2 power n power 2, and n log n. The best scenario is like O log n and O1, which like almost impossible to achieve. Normally, if you get into the orange area here, which means you are like very good at it already. Okay.
What is the log? What is the log stand for?
Right, that's too specific. I forgot. Log n. Simple. Okay. So here's a, for example, log 2 of 3 equal to 2. Man, It's very hard to explain. It's very like mathematics. And normally, like people in Vietnam learn this a lot during their high school, right? I forgot all about those. Sorry. But you need to know how to calculate it. All right.
An example of this, so we can easier to visualize this one.
Yeah, you need to do a couple of algorithms to see how it works. Where are we? Shit, this one is blocking. This is a problem with Zoom, guys. This is blocking your view. Always. I'm gonna write down. Remove this. Remove this. So normally you will have like your algorithm will be about this and square. Normally, yes. It's very hard to achieve the orange area here, let alone the yellow or the green one. It's very hard. So here's the, it's not 100% correct, but it's kind of like a reference to understand the sorting algorithm and how fast it is on the best case, average case, and the worst case. Also, you have the space complexity as well, this time and this space. So to me, I would say Marshall is very fast. I think it's the fastest algorithm in the 4 algorithm that we will learn today, Marshall. But it consumes like a lot of space comparing to other sorts. Okay. So today we will learn how to like implement 4 sorting algorithms: selection sort, bubble sort, quick sort, and merge sort. Quick sort and merge sort, there will be magic behind it. It's hard. You have to use something called a recursive function to do that, like you calling itself. But for selection sort and bubble sort, you only use for loop, and that's it. So let's take a couple of minutes to recap everything before we jump into the lab. Okay. I know it's short. The theory is short, but you have to actually do it in order to understand them. So do you have any question? I like this one. It's stupid, it's fun. Let's see the chart again. Sorry. Let's take a look at the chart. Normally, your algorithm will be O and square. Okay. And it's good. It's already that good. Even though you can see on the chart here, say horrible, it's okay. If you can make it n log n, it's so good. You're very good already. And it's very hard to achieve the yellow area here. And here's the results, like approximate, not 100% correct, but approximate. So we will learn quick sort, merge sort, bubble sort, and selection sort. Oh my God, selection sort is so bad. Yeah. As you can see here, quick sort and merge sort is very fast comparing to bubble and selections. I think this one's wrong. It should be in O and square. Yeah, this one's wrong. It should be O and square. Merge sort is very stable. Okay. Questions? Don't worry if you don't understand this, like this thing today. It's okay. I swear. I was like, what the heck is this? At the first time I learned this. Don't worry. Question. Okay, there's an explanation from he. If you have n power 3 to 8, okay, yeah. Okay. All right, do you want to do the burger shop right now? Well, it's easy. You said, yeah, it's easy, but you need to understand how to shuffle it. I think how to shuffle is very fun. You have too many ways to shuffle a deck of cards. So let's go. Open your lab, and here you have a link. Inside the lab, you have a link like enroll this in this class. Click here, and wait, what? Can you click it?
The algorithm.
Did you click it? Okay. So what's the result? Actually, I have a couple of different classrooms, so I see a lot of them. So click here. If you have it, it will take you to a classroom which have like 5 assignments, 5 questions, 0, 1, 2, 3, 4. Okay, let's start with Bogo Shop first. Okay. I don't know. I saw this a couple of times, and every time I wrote it differently. Okay, unsubmit. Delete them all. Too small to see. Holy shit. Okay. So this question is to implement the Bogo shop. Okay. So assume that we have an array, cos array equal to 4, 5, something, just randomly input. 0 maybe. And here I'm gonna put 8. Oh shit. What the hell is it? Okay. Assume that I have this array. And that's too long for Bogo shop. Sorry, that's too long for Bogo shop. It may take forever, I don't know. But yeah. So here I want to sort this array using Bogo shop, meaning I randomly shuffle it until it's sorted. Okay. So I need to create a function to check if this array is sorted or not. So we may have to need this function is sorted. Okay, and it take in an array as the argument. Okay, and another function called Bogo short. Also array. So this function gonna return the array. Yeah. Clear? Right. The more is so small on my screen. It's okay. Okay. So how do you check if an array is sorted?
Follow order.
Hmm?
Follow order, I guess.
Yes, it has to follow another, like to smaller to greater, right? So we need to check a for loop, use a for loop, or you can use map or for each, but using for loop is best. For loop for I, sorry, array dot length. Okay, then we increment I for every iteration. Okay, so how do we check? How do we check? You don't have to copy the code, just look how I do it, and you have to do it yourself later.
So if array I is smaller than array I like plus 1.
So meaning you compare the current index with the next element, right? Next element next. Okay. So if array I is what? Smaller. I plus 1. What happens if it's smaller?
Then go to the next side, like I plus 2.
Yeah, that's the logic, but you have in code you have to write differently, the opposite. Okay. Yes.
Greater than I plus 1 and return false.
Yeah, exactly. So in code you have to write differently. Return means you can stop the whole function. You return false. Else, finally, you return true. So that's how you write in code. Okay. So here, the purpose of the function is to return true or false, right? In programming, it's very important to know the data type. For example, this function, you're going to return true or false. And when you return in a function, it means the function is stop executing. And here, if we find any element that is greater than the next element, we stop the whole function right away. We return false right away. Else, we do everything until the last element. After the last element, if we have yet return, then we will return true, meaning every single element is less than the next element. So we return true at the end. So that's how we write. Wang explained like her logic is correct, but to write in code is the opposite. Okay. And so if we want to make sure this work, just console log it. So I'm gonna disable this and console log array. No, is shorted. Right. Okay. R. So R we got from line 3. Check it. False. It's not shorted. So if I change it to 1, 2, 3, let's see what happens. 1, 2, and 3, and run it. True. So the function is correct, right? Go back. So next step, we want to do BOGO sort. So we have the function to check if the array is sorted or not. So now we need another function to shuffle it. Yes?
So do we need to make the I less than array roughly minus 1? Because otherwise the I plus 1 in the if would be
Yeah. Wait. So here, take a look. I less than array. So we should start from I1. And then we have to change this a little bit. Minus 1 greater than I. Right? We start from the second index, not the first one. And then we compare it with the previous one. It's better. Thank you. But why didn't it throw the error earlier? That's weird. It's throw error. But anyway, so this is the correct function, I would say. Okay, false. I'm gonna get rid of this and let's work on a shuffle. Function shuffle. All right. So in the lab here, I explained if you have, yeah, it's all. Okay, in the lab here, I explained on the algorithm that I use for shuffling. It's called, it's from the guy who called Fisher Yates. If you wonder what the hell it is, click on it. Blah, 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 blah. A bunch of things, right? That's long. But basically, in the code here, we still iterate through the whole array, right? We start from the last element to the first one, and then we wrap it. For every iteration, we randomly swap the element with the remaining elements. So, like for example, if I have an array of this array, so the first iteration I will grab number 1 and I will randomly swap it with any of these. With any of these. Okay. So the first iteration is going to be 4, 1, 2, 6, 2, and then this is going to be 6. Okay. I target 1. I randomly swap it with any element here, any of them. So here in this case, I swap with number 6, the second index. Okay. Swap it. Then the next iteration, I will start from 2. So I will pick 2 and then I randomly swap it with the rest, maybe 4. So it's going to be 2, 1, 2, 6, 4, and 6. Okay. Just keep on doing that until we finish the loop. Okay, that's the idea of physics shuffling. So how do we do it in code? Still same thing for loop. But we start from the end. There's a reason why we start from the end, not the first index, because if you want to target the remaining elements, it's very hard to if you do it from the start, beginning to the end. So we do it array dot length -1. Okay, and then I is greater than 0, greater than or equal than 0, right? Semicolon I minus. So here we go. Correct? For I, yeah. Okay, now we have to swap. Oh my God. So we need to target the I will start from 1, the last index. So it's going to be array I will be 1. But we need to decide the random position of the target, right? We want to target the random elements. So we need to define the random like position, the index. So I'm going to say const random index equal to, how do you select a random element inside an array? So what does mark random return? Correct. It's not random number. It's random number between 0 and 0.9999. Okay. So you have something called mark.random. How do you call it? Random like this, right? But you have to multiply it with something in order to get the number that's above 1. So here you may multiply it with array length. Okay. And array length can be 0, so you may have to plus 1. Array.length plus 1. And we don't target the whole the decimal place of the number. We only want to target the integer part. Okay, so we're gonna use mark floor. It looks so much better. Shit.
Can you explain again why we start from minus instead of plus?
Sorry?
Array.length -1.
Array.length -1. Okay. We want to, like, we start a loop from the end of the array, not the first index, from the last index. So we want to look backward.
Why?
Because of this, we want to target the remaining elements inside an array. If you start from the beginning to the end, it's very hard to target these. That's the question I asked. Sorry, what's your name again? Vin? Yeah, that's the question I asked Vin last week. Why did he choose to look backward? And he answered it correctly. So you will see. You may try to do it by looping from the beginning to the beginning index to the last index, right? You may want to try it, and you will see how hard it is. Okay. So now we got the random IDX. Okay, so now we need to swap it. We swap the value. We swap, for example, we got a random 6 index, which is 6 here. Want to swap 6 with 1 in array. So how do we swap it? We have traditionally we can do a function like this, function swap. Inside swap we have array. The first index we want to swap, and the second index, the target index. And here's how you would swap normally. Let temp equal to array I, for example, and then array, not array, I equal to j, and then j equal to I. Okay, I'm sure that you already you have already done this in your JavaScript exercise. Maybe not. You should know this. There's a better syntax. It's come from JavaScript ES6, which is I j equal to j comma I. They're the same thing, right? So this line means you do all these 3 steps at the same time. It's a better syntax, but don't do it. It's very hard for people to follow. So just don't do it. Okay, just use the old way. Assign a temporary value to Ri and then swap it. Okay, now you can use it here. Swap. All right, and the first index, it doesn't matter the order. It could be I and then random index, or random index first and I later. It's okay. Doesn't matter. So finally return the array. Okay. I'm not sure if the function worked yet, so we have to check. Yes.
For the random index, when you need to plus 1 from the array, right? I think it's fine to get 0, right?
Yeah, but imagine that if you let me see, because you get the floor, right? If you have if I is 1, what happens? Let's say if I is 1, what happened? What's the math law? 1 multiplied by 0 point something means 0 point something, and math law will be 0. So you have 2k of 0. I is 0, I is 1, they are both 0, right? Does it make that?
But then you would have a case where it's larger than the array.
So, okay, so let's start from here. How many elements here we have? 3, 4, 5, 6 elements, right? So if we have 6 elements and we got the random number here, maybe 0.9999, which is less than 1, we multiply by 7. What do we get? 6 point something, right? 6.9999, for example, and then we still get the math law of 6. The result will be 6. 6 is the length. Random index, so it will fail, you mean?
Plus 1, you get 7.
Oh shit.
Which we don't have.
Minus 1. If we minus 1, then yeah. If we minus 1, it doesn't make any sense.
Then you get 6, but don't have anything else.
Yeah. So it had to be. So let's try with no plus 1 and plus 1. See what happens. Okay. So let's see if I run into any error. Undefined. Oh shit. Because out of index. It worked with our plus one.
Mark for make it positive.
Oh, really? So we lost one here. Let's run again. Now we have too many one. Something wrong. What's your suggestion, Vin? Minus one? Or just keep it? Okay, how do we get a random element inside an array? This one we have to do with I here. Shit.
Can you explain the logic of
Oh, for swap?
no, the whole function?
The whole function swap? Shit. Sorry guys, I'm gonna quit this. So annoying. Okay, the whole function shuffle is like for example, we want to target, we look backward, right? We look backward, we start from one here, and then we swap one with any of these elements. So it could be 4 here, and then it's gonna be 1, 6, 2, oh, sorry. Yeah, 2, 6, 2, and 4. First time we run. The next time, no. I don't know why, but we still have it running. Can you hear me? Hello, Hui. I think
Yes.
All right. I don't know why, but we still have it. And luckily I record the video on my computer, not on the cloud. Okay, the next iteration is gonna be like, let's swap it with the same. Maybe the same element here, with the same index here, for example, or you can choose 6, I don't know. Maybe choose 6, right?
So the second time you will swap the
2 with 6. Yeah, so 2, 6, and then 6 and 4 here. Okay. So we're done with the 2 elements here. Now we swap 6 with 1, 2, 2. Any of them. So that's the idea of 58. Shuffling.
So I think you should still start from when it should still be 6, which is array minus 1, but I think you should have something like y the random index is equal to I, and keep continue.
The random index equal to I.
Because if the I is more than 6, then you can still get the same number.
So you mean here I have a condition, another condition, if I is where's y? A while? I don't think you need while though. So while is kind of like for loop with condition, right? We can do a for loop without a while.
You do it until it's different. There may be some cases when they keep getting same results.
So random ID x here, the first time it's run, it will start from 0 to 5 max. The second time it runs, it's going to be 0 to 4 max. All right, that's the whole purpose. This line, random index can be 0, 1, 2, 3, 0, 1, 2, 3, 4. What? How many elements we have? Okay, 0, 1, 2, 3, 4. It could be 0, 1, 2, 3, 4. Right? The second time run, it will be 0, 1, 2, 3. Right.
So it needs to be the random number needs to
Minus
from to I.
To I.
Otherwise, the second time it will be over the I.
So you mean I here?
Yeah, if you want to.
So the first time it's run, it's gonna gonna be 0. It's always be 0. The first time run, it's always be 0.
No, because the I goes from.
Oh yeah. Shit, I started from backward, sorry. Oh shit, that's why I, then I plus 1.
Sorry, but I don't get it. I don't get it.
Yeah, it doesn't matter. Okay, start from I. Still missing 1. Shit, this really annoys the hell out of me every time I do it. There should be a fix here.
It didn't work with just array length without length.
The length. The purpose here, we don't want to select the last index as well if we're done with that, right? So we cannot use the length. So we have to use I. I's will start from 5, 5, 4, 3, 2, 1, right? 5, 4, 3, 2, 1. So we get a random. So we got the math floor. Which is correct. I don't know. I don't see anything wrong with this. So. Let's see again. Okay. Yeah. So let's construct. Let's construct random. Construct to see this variable a bunch of times. Let's see. The first time is 0. It's 2, 2, and then 0. How the hell it got to 0? Oh. Why so many 0? It's weird.
Can you tell me the last case, to swap the last one, what it should be?
Okay, let's swap again. Let's swap the index and random index I and j, temp. Oh shit! Oh my gosh! This here! Oh my god! What the hell is this? It should be temp. What's the whole purpose of temp here? Oh, no one spotted it. Oh my god! The stupid mistake I made here. Should be assigned temp. Like what the hell? Why do I even need temp here? If I don't use it, right? Sorry guys. Try again. Run. So now you see it swap, right? It does swap. 3, 4, 5, 6. 3, 4, 5, 6, and the number is same. Just swapping the position. Okay. So everything worked fine until because this time I forgot to use it. Let's run a couple of times. We still see the result we want. Okay, nothing wrong. So no matter how many times I run, you always see 2, 6 and 2, 2 and 1, 1 and 1, 4. Okay. So that's cool. Similar as work.
How about the for loop should be I greater than 0, not equal?
Wait.
Because if I is 0, then it will just swap with itself.
It doesn't matter. It's what we said. Doesn't matter. It's okay, right? Yeah, you waste one iteration, but it's okay. I think same thing. Right. Cool. Same thing. And now I'm going to remove the construct there. So our problem before was the temp. Actually, the temp is the killer. I forgot this. I should have used the syntax. This I'm more comfortable with this. This is how you use in Python. Okay. So we're done with the shuffle. Okay, let's move on to the function Bogo shop. So here's the main function, our main function. So so now we use while. So here's the syntax. while this array is not sorted, we shuffle it. Okay, that means the same thing. While is sorted, we call a function is sorted, and we pass in the array. While this is true, we keep shuffling it. Array equal to shuffle array. Okay. Oh shit, what is this? Then we return array. Very simple. This function is very simple, but the logic behind it is we have to do three things here. Okay. If this array is not sorted, we keep doing this. We keep shuffling it. If it's sorted, we return it. Right. And now I'm gonna console log Photoshop. See what happened. Okay, it's sorted. Yay, Photoshop is not that easy. I like it. So let's recap everything. So it's the main purpose. Our main purpose is this function. It's very short. It's just 3 lines. Okay, but in that we have to check if the array is sorted or not. If it's not sorted, we have to shuffle it. And then we have to come into another question: how the hell we check it if it is sorted or not? So the answer is here. We need to iterate through the array to make sure the next element is greater than the previous element, right? Okay, that's answer to the first problem. The second problem is how do we shuffle the array? Like randomly. How do we shuffle it randomly? So you may Google how to shuffle an array and you will come up with a couple of answers. And one of the most famous solution is the Fisher-Yates solution. So his idea is like take the array and iterate through the array starting from the last element to the first element. And then swap the position of the current element with the remaining previous many elements. So here's the code. It's one hell of the code. Okay, and then return the array. And that's it. Do you want to try to see if this works or not?
Yeah.
You may like this syntax. Okay. So disable this, comment this, run again. Yeah, basically the same thing, right? Same thing. Same results. So you can either do this or do this. Right, so that's it for the Bogo shot. You may take a break and then we will start with the real thing. Yeah. Question. Copy the code or not? Huh? Okay. All right, guys. From the starting from the backend module, I will not let you guys copy and paste the code because, like, you have to actually code yourself. You can watch me do it. You can rewatch me do it. You can ask me why the hell it has to be like that, or why it has to be like this. But you have to actually think and code it by yourself. Because the backend logic is all about the logic. So you may call it differently, I may call it differently, but I expect you guys to come up with your own code. That's what I want. So I may have the shortcut if you want. I will post the shortcut on GitHub if you want, but I expect you guys to actually code, not have the result next to you and then start typing like this. I don't want to see that. Okay. You may find it's very hard at the beginning, but yeah, last class they complained the backend is so hard because I try to have so many topics inside the backend. So I want to prepare you that when you actually go to work, you know, like almost everything about the basics. Okay. And if you feel like the pace is too fast, you can stop me so I can change the content of the labs. Okay. Actually, I have the shuffle and the swap in the lab. Oh shit, let me stop this.